Good morning. Day 2 in Iceland. Still windy.
I got a pedicure in Singapore that was desperately needed. It was in the fanciest mall. Unfortunately, it was like a tech mall. Very minding my own business, as one does when you're getting a pedicure. And she pulls out this thing before I can even pull my phone out to.
Okay, what's happening?
And her on the doll. The masseuse.
Shit.
Ass up.
Ferris wheel.
That's the way we like to play.
There's a creme brulee donut somewhere. Ooh, the art museum. A art museum.
You're 5'9".
Have you ever heard of Sir William Stevenson? He is a true spy. So Matti knows this place that has creme brulee donuts, and I see a cruller in the window, and I'm very excited. Very excited for everything. You know, I just want to take pictures. It's torched.
Too lazy. Have a picture last time.
I'm so excited. I had no idea this was happening. Excellent.
You want to be an undergrad at UConn?
Oh, I was. Oh, I was not actually. Wait, is this all the stuff that's like left behind? The Baden family 2024. This is recent. This is... Wait, this is in the future. 11/12/2024. Oh no, that's not right. July 12th, 2024. Wait, this is super recent. Fascinating. All the stuff on the table. Walking through town a little bit. I forgot a hat, which is my bad. I mean, we were kind of leaving pretty quick. But there's a puffin fighting a polar bear, so that's cool. Cute little part of town. This is like kind of the town square little area. Lots of cool stuff to look at.
This fast food restaurant is very good. Get some really good ice cream.
Ice cream. I want this on my wall.
There's a thing over there called Omnom.
Omnom. It's Omflam.
No, it's Omnom.
It's Omflam.
It's a restaurant. Omnom.
I'm pretty sure it's Omflam.
No, I almost went to it.
And it did not.
Nom.
Okay. We are all checked in. We got some lava, but we also got a token we can use to exchange for a drink of our choice. We have a gift shop as well. It's very cute. It's a very small business and they do stuff with lava, which is really fun. They have screens over there where you can see the volcano from yesterday. They have like the live feeds up from different viewpoints, which is also really cool.
Where I take you to die.
Okay, we have the premium experience, Mr. Dramatic. So there's a back staircase that they have us go up where we can hang out, I guess. Oh, nice. Volcano. That looks insane. And then they have the same TVs up here where you can watch them. The bar is up here. Oh, very nice. Oh, is this like what people would actually wear? See that? Lava bubbles. I don't know if this is better. So the extra lava rocks say that this little piece is from the 1918 eruption. And then this is what it looks like. And we'll probably get another piece too. Very fun. Look at that. It's like glass. I mean, it is glass.
Pretty sharp, actually.
Yeah. We have been seated and just looking at this like forge. Very excited. It looks like the Stargate or I-1 when they're about to burn Vala.
What a deep cut.
Can everyone hear me clearly?
Yes.
Perfect. Then everybody, welcome to Lava Show. This is going to be the only place in the world where you can see real molten lava poured inside of a building. So I'm going to be your host today, and my name is Madison. And maybe you can already tell, perhaps from my lovely accent, that I'm in fact not Icelandic. No, I am from the United States. I'm from a small town. It's called Bremerton, Washington. And this would be Washington, the state on the west coast, not Washington, D.C. That is the other one. We're heating that lava to over 1,100 degrees Celsius, so it can get really hot back there. I know the suit looks a little silly. He really does have to wear it though. This is a volcanologist suit. That's what you'd see a volcanologist wear when they collect samples from erupting volcanoes. He has to wear it, so when he opens the furnace doors, he doesn't get turned into Crispy Bacon Man. That would be bad. Now if you notice up on this visor here, it's gold plated. This is the same kind of gold plating put on an astronaut helmet when they go to space to protect themselves from the sun's radiation.
Cool video. Very cool video. The Reykjavik Peninsula is the newest. Hi, this is Nate from the future. I just wanted to give like a really short description of the video, at least what I remember of it. So the video was really cool. It kind of just went over like kind of the basics of plate tectonics. And then after that, it then started to discuss like the history of volcanoes in Iceland and talking about like the different regions and the different volcanic chains, the mountains that make up like the different pools that start to erupt. And so talking about like different sections or different parts of the country that have had volcanoes erupt and how that's affected the population growth and how kind of like they kind of were a little ominous about like how the Reykjanes Peninsula, which is really close to Reykjavik, has been quiet for a long time, but now it's starting to get more active. So they were like, well, Reykjavik has gotten big because there haven't been volcanic activity there for 800 years, and now it's starting to come back. So it was really interesting. The video was really cool. I bet you could probably find something like it online, but if not, then yeah, just a little bit of memories there. You can feel the heat. It's hitting ice right now.
Again, so what we're seeing here, this is a typical Pohoi type lava flow. Pohoi lava flows are extremely hot. They've got this very fluid, liquid texture to them. They've also got this really, really bright glow. Now this here is something called Pele's hair. Pele's hair are these very thin filaments of lava. Now they do get formed in nature, but this happens when lava goes usually off of an edge or it just gets picked up by the wind and it's going to get spun into a very fine strand. Pele's hair are named after the Hawaiian goddess of volcanoes. Well, her name is Pele. Except in Iceland, they don't have a goddess called Pele. So in Icelandic, they were called witches' hairs or Nornahau. So the hairs do cool down very quickly. Pele's hairs usually go from orange to black in just a couple of seconds. Because of how thin they are, that does make them rare and difficult to find in nature. Just because around an erupting volcano, something that's this small, it does get destroyed immediately out there. So now I'm going to grab a second block of ice that I have, but this one's going to go on top of the lava. How about there? And then I'll just add a little pressure to it.
very warm in here. And the water is melting. Oh, it's bubbling up.
So as we can see, we do have something different happen this time. So if you look at the surface of the lava isn't moving anymore. The top layers of lava will begin to solidify very, very quickly. So then now when I put the block of ice on top of it, it does turn to steam, we can see that. But the steam is also getting trapped in the lava. So as the trapped steam will try to rise and get up and out, it inflates the lava up, kind of just like a balloon instead. So that top layer has become solid. What I'm going to do is now get underneath here and I'm going to pull it up.
So just pulling it up right in the center there.
As we're going to see where I have the stick, it bends. The outside layer does hold. Underneath, I have a little bit of fallout. Because actually inside the channel is completely
Still
liquid.
so hot.
It insulates its heat. So I can manipulate it. At the neck, it's clearly pulling apart. When I let that go, it's going to somewhat hold that shape. So then I'm going to come down here, and then I'm going to just put this up and over. So underneath, you can see, clearly we also don't have solid lava under there. That is very much still liquid. What I'm going to do is I'm going to get underneath here as well and just lift this up a bit. You can see on the underside how it falls out. I'm going to come do this on the other side as well. You can see it all come down.
It's like right there in the middle. It's still falling down that way. Pulling it from the far side. I feel a little better now.
So once I take the lava out of its insulation though, once I expose it out to the open air, it is going to start to solidify. We can already see that because we can see the textural change in it. But solidifying lava, it goes through stages. It doesn't go straight from liquid to solid. It has this middle phase where it's sort of more gooey, if you will. It's a little bit more stretchy. So if I can just get this bit here, and I'll stretch it out. So you can see it's not like the Pele's hair where it was super liquidy. It holds together. It kind of feels like melted sugar or taffy. You can see underneath where I expose it, it's much brighter, where it's hotter. Parts of it are darker, some of it's already turned black. And I can stretch, and I can stretch, and I can stretch, but eventually it does reach a point where it doesn't want me to stretch it anymore, and it's either just gonna break or pull itself apart.
Dang.
Like that.
Cool.
So this is what I mean by middle kind of phase cooling. It's you know, it's very obviously not quite as solid yet. It's still moving around. I can still kind of bend it around, but it's obviously not really a normal liquid either. So it's both and neither all at the same time.
So it has better color balance.
Let's see. Let's see if I can take this one blob one more time. I think this is the last bit that's going to be liquid enough for me to pull. Again, we're going to see the brighter underside, and it's going to stretch. Where it's very thin, it turns black, and then it's going to break apart.
Very cool. I don't know why I have two cameras, and they have different colors. It's very weird.
And now we're going to let that completely solidify. We can hear this sound now. This crackling, this crunchy sort of noise. So what this sound is, that's the sound of the lava becoming more solid. So solidifying lava has this noise because what it's doing as it cools down, it's shrinking. As the lava shrinks, it has to contract. And that's what we're hearing. Cooling and contraction of lava as it becomes more and more of a solid. Alright, so that sound is going to be familiar. What's it sound like when the lava breaks?
Glass.
Exactly. So, specifically, it's the iron in it that's going to cause it to be black instead of it being a true clear. Alright, I want to break into that, but it doesn't appear to be ready, so I'm going to let it sit for just another minute or so. I can't break the lava until it is completely solid, and I really want that piece, so I'm going to let that solidify. There still seems to be a little bit of stickiness in there. Now that I really have the lights up on this, and I did hear something at the counter earlier, I heard the word obsidian. And a lot of you might be thinking that this is something called obsidian. Okay, so who else has heard of obsidian? Yes? Okay, see lots of hands. Perfect. So, obsidian is by far the most well-known type of volcanic glass. It is also one of the most common types of volcanic glass there is in the world. And volcanic glass and obsidian, these two words, because of how common it is, they often get used interchangeably. However, this is not entirely true. Volcanic glass is not always obsidian. So in the world of geology, we have a few different kinds. I use volcanic glass because that's the general term and it encompasses all of them. Obsidian is one specific kind of volcanic glass, but only one. In order for a volcanic glass to be actually called obsidian, to have that geological name of obsidian, it has to contain 70% silica. It has to come from a lava type called rhyolite. Our lava is not that. Our lava is only 47% silica. Our lava type is called basalt. So on these chemical technicalities, this one cannot have that name of obsidian. This one instead gets the very fun name of tachylite volcanic glass. It's not as catchy though. It looks exactly the same as obsidian. It is formed in the exact same way, but different chemistries of lava equal different names of the glasses. All right, now I got my piece broken, so I'm gonna.
Still glowing.
So we can see this black outer.
That was a cool show. We had a fun time. Also, fun fact that she told us at the end is that you can't drown in lava. Now we have a backstage tour of the furnace room. Oh,
It's literally
cool. Oh, it goes outside. That's why it's so cold. Cool. Is that not on?
Our furnace room. You are in for a treat because usually it is really hot in here. So it's a windy day, so we have air draft. But anyway, welcome to where we built our lava. Originally, this furnace you see here is out from the United States, from Michigan. It was intended to be used in the car industry, but you can't just throw rockets at any furnace and have it turn into lava. So we had to make a bunch of modifications and create the lava furnace that we have right here. This is gas powered, and the gas that we use is methane. The methane comes from down the street from a landfill nearby called Sunpop. So basically,
cool.
all the food we throw here gets sent there, decomposes and creates methane gas.
Nice.
They bottle up the methane gas and send it over to us.
Very cool experience, all in all. Matti saw this hallway and got really excited. Then also, yeah, just enjoying the ambiance. Very cool day. All right, I've been working for like 4 hours trying to get some stuff done, some hot docks out. We are still sailing and there's still land, so that's cool. But we're on our way to Greenland. Woohoo!